Understanding triggering is one of the most important things when learning how to use an oscilloscope. This is even more true on today's digital storage scopes. At its most basic, an oscilloscope monitors voltage over time for each channel or signal that is connected to it. But in its normal mode, it doesn't just continuously show the most recent voltages. To help the engineer visualize the signal, a scope overlays waveforms from different points in time that share a specific characteristic that is of interest to the engineer. This characteristic is the trigger event. There are several important settings to discuss before we discuss the variety of trigger methods. First, trigger holdoff is a setting used with many of our trigger types. This sets the minimum time between two triggers. This is used to make sure the instrument doesn't trigger on an unwanted signal between the trigger events we want to capture. Here we are looking at a series of pulses. We can use the trigger holdoff to make certain we only trigger on the first pulse. Now, the trigger event is the first pulse in each pulse train, since the pulses end before the trigger holdoff expires. Each time the pulse train starts again, a new waveform is posted to the display, overlaid with the previous signals. This is how we use triggering to show how a signal changes over time. This makes it easy to see how many pulses are occurring in a set. Another important concept to understand in triggering is pre-trigger and post-trigger data. Typically, the scope places the trigger point in the center of the display. Points to the left of the trigger occurred before the trigger. This is the pre-trigger data. Points to the right are the post-trigger data, as they came after the trigger event. During a real measurement, as the trigger moves around, you can see how much of the data is before or after by referring to the infographic at the top of the display. The orange trigger marker denotes where the trigger occurs in the waveform. The grayed out area denotes how much of the data is off the display. This is especially important when using the deep memory of the oscilloscope. Once you stop capturing waveforms, you can then move to view parts of the waveform that are originally off the screen. Triggering is a reference point for how we compare and evaluate signals. Understanding the basic concepts and different methods of triggering makes signal analysis more effective.